In this video, we want to do a true and fair comparison of standard offset style strategies and the iMachining toolpath. And then we'll also compare the iMachining wizard and its feeds and speeds. What we have set up is we have a standard pocketing toolpath cutting the outside of our part. This is a standard parallel offset, as we can see, in one-way cutting. The second operation we have set up is an iMachining toolpath for that same geometry. So let's go to the pocketing toolpath and let's pick some real-world feeds and speeds. What we have here is we have a 1/2" end mill, 4 flute. So let's say we'll start out with just a high-speed steel 4 flute roughing end mill, cutting steel. So if we were to pick some real-world feed speeds, assuming we're not doing high-speed machining, if we were cutting steel, we'd probably run something around 100 surface feet and pick something around 4,000 ship load. This ends up working out to roughly 760 RPM and a little less than 12.5 inches a minute. If we were using a roughing end mill, chances are we'd be able to do this cut in one depth of cut. It's 900 thousandths, and we'd be able to most likely get away with it. So what we'll do is we'll compare the cycle times for this feed and speed at one depth of cut, and then we'll also cut the depth of cut in half, and we'll do it in 2 passes and see what the difference is. We are using a 60% step over on this part. So if we save and calculate and go to our simulation, we can see here we have our feed rates and our running time, and we'll just quickly play this toolpath. We see we end up with 13 minutes and 30 seconds, roughly 13.5 minutes. If we were to change this cut and we were to use, let's say, we'll pick equal step down and a half, which will give us 2. If we were to go and play this, we end up with almost 25 minutes worth of cycle time to machine this outside steel part. To give you an idea of the size of the part, it is roughly 12.5 inches by 6 inches long. Now let's go take a look at, if we use those exact same feeds and speeds, the 763 RPM and the 12.5 inches a minute with an iMachining toolpath, what are we going to get? Now most high-speed machining toolpaths on the market today, they will tell you that most of their strategies need to be using high-speed feeds and speeds to be more beneficial than the standard style strategies. In iMachining, we don't believe that. So what we're going to do is we're going to disable the wizard entirely, and we're going to run our own feeds and speeds. So we're going to pick a RPM of 763 and the feed rate of 12.5 inches. Going to go to our technology. We're going to do one depth of cut. Since we're using a roughing end mill, we're going to maximize the step over, which is at 80 degrees is 200 thousandths roughly. And since we're also trying to mimic what we get in parallel strategies, we're going to pick a bigger minimum cutting angle. We'll calculate this toolpath, run to our simulation, and we'll see what we get. We see the iMachining toolpath is 12 minutes and 7 seconds, roughly 1.5 minutes quicker than even the standard pocketing or offset strategy with the same step over, feed, and speed. Now, how does iMachining do this? It does this by a couple things. First, as we look at the toolpath, we see there's very little clearance and retract movements. Because iMachining is doing smart repositioning and always staying in the cut, as we look at this part, we're not wasting any feed Z moves, and we're not wasting any clearance moves. So you're getting a very big optimization just by keeping the tool down inside the cut the entire time. The second thing we do is, we know we're not always going to achieve the step over that the toolpath we ask from it. And when that happens, we're automatically adjusting the feed rates to handle that. So even if we were to start single stepping this, we can see in the beginning as it's entering the cut, we know we have less step over. So our feed rate's actually a little bit higher, and it gets up to 17. As we hit the full depth of cut, you can see we're right at our roughly 12.5 inches per minute. So iMachining is being intelligent. It's getting rid of the repositions. It's staying in the cut the entire time. And it's adjusting the feed rate when the step over or the width of cut is falling below what we specify. So very efficient feeds and speeds, and you get a very nice toolpath. This is also going to be better for the tool in the long term because the tool's also staying in the cut more. It's not entering and exiting as much as it would with standard pocketing or standard offset cutting. So this is a comparison of 13 minutes, 13 and a half to 12 minutes. Not a huge difference, but even using same feeds and speeds that any shop is used to, we're going to see a benefit with iMachining. And not to mention, when the tool path is running out on the machine, as an operator, you're going to feel much more comfortable not having all of those Z clearance retracts and plunging all the time with your hand on the cycle start button when you're running the first piece. So iMachining also gives you a better feel at the machine because the tool path is staying down and it's cutting more intelligently. Now let's also take a comparison of what happens if we were to try and do, let's say, high-speed machining with like a carbide end mill. Our customers using high-speed, they're using carbide end mills today. So let's say we went back to this pocketing end mill. We're still going to use a 1/2 inch. We're going to still pretend it's a 4-flute carbide end mill. Now we're going to switch things up a little bit. Now most likely if we're running carbide end mills in steel, what we're going to do is we're going to run more surface footage, and then we're also going to run shallower depth of cuts because we're not going to take the full 900 thou at that step over. So what we do is let's say we want to run something like 2500 RPMs. So a 1/2 inch end mill at 2500 RPMs works out to 330 surface feet, which is a little on the high side for steel, but for people doing high-speed machining in steel, really not that high. Definitely doable. So, and then if we look at our feed rate, we get roughly 40 inches a minute. So 2500 RPM, 40 inches a minute. We'll go to our levels, and what we're going to do is we'll pick a 1/4 inch depth of cut. I personally feel that's a little heavy with a 4-flute 1/2 inch carbide end mill, but it really depends on your machine, the rigidity holder. So a 1/4 inch depth of cut is not unreasonable. Maybe it's a little high for some machines, and even other machines might even be able to go a little bit deeper for sure. So let's calculate this toolpath, and we'll see what cycle time we get. So if we see here, we're sitting at 15 minutes and a half, almost 16 minutes here. So this is a cycle time at a 1/4 inch depth of cut at 2500 RPM and 40 inches a minute. We can see basically the same toolpath we had the first time. Now we're just trying to go with shallow, a little bit shallower depth of cut, more RPM, higher feed rate. Now let's go to the iMachining toolpath, and we'll do the same thing. So we'll go to Tool. We were running 2500 RPM. We're running 40 inches a minute. We'll also mimic the same step over, so we'll pick a 1/4 inch, equal step down, and we'll calculate the toolpath. "15 minutes and 53 seconds. So basically you got the exact same cycle time going between standard pocketing with high-speed machining and iMachining. Yet we're keeping the tool in the material the entire time. You're getting less wear from the tool entering and exiting, and it's also doing smart repositioning. Now let's do some comparisons on what iMachining's wizard would tell us to run. Because now that we're actually doing step over control toolpath, we can take this thing in one depth of cut. Not a problem at all. So we're going to turn the wizard on, and we're going to take a look and see what the wizard generates. So first, let's not go all the way up to level 8. Let's say we're trying to be a little conservative, and let's go step down to level 3. Now, when we step down to level 3, a couple things we're going to notice here. iMachining, unlike what we were doing with standard pocketing, is going to do a smaller radial width of cut. This is because now we're doing full depth of cut, so we wanna shorten up the width of cut, so that way we're not getting into a heat condition. When we're also doing this, we're going to adjust the feed rate for chip thinning, so we're running a constant chip thickness. Now if we look, see, iMachining does some different things than what we do in standard pocketing. When we're using carbide end mills, we're going to try and hold 2 thou and 7/10 of a chip thickness. So what this means is at the 61,000 step over, the 125 inches is going to meet that 2 7/10 chip load. Now iMachining is going to run up to 6100 RPM. This is going to be no problem with iMachining at all. The biggest reason, as we know with standard offset style strategies, When does the tool make the most heat? When it goes into the corners. We've all seen as the tool path, as it runs into the corner, you can see it smoke up. I mean, we've all basically had the coolant just dripping on it, and we know as it's cutting around the outside, it's nice and fine. As soon as it goes into a corner, the tool starts to smoke and the coolant evaporates, because the heat generated in the corner is what's dictating the entire tool path for us. Even though we knew if we were running in a straight line, we could run 6,000 RPM in steel, that wouldn't be an issue. Not at this step over, not at that depth of cut. But the issue is, in standard pocketing and standard offset style strategies, we're getting a too big a step over in the corner, chip thickness is going through the roof, and we're slowing down the entire tool path because of it. So if we looked at what iMachining would do for this strategy at this step over, we'll see what time we get. Now what we're going to see is, one, you're going to see a lot smaller step over, but we can see what happens. We go all the way down to 4 minutes of cycle time with iMachining. That's still a very, very conservative feed rate and RPM with iMachining. We do have to remember, this is much higher than the 2,500 RPM we were running in standard pocketing, but we're limited in standard pocketing and offset strategies because of the corners. Now, even if we were to take iMachining down to, let's say, level 1, which would get us down to roughly that 2,500 RPM range, a little less. And as we say, level 1 is here to be very safe. This works really good when you have a part that's maybe hanging out in there and you really don't have a lot of cutting force, or your tool is hanging out very far. Now even if we do this, we see we get the 17 minutes. So that is 2 minutes more than what the standard rough cut did with the standard offsetting. Yet we're actually still running a little less RPM and feed rate than we were in the pocketing, because this is only 2,200 RPM as opposed to 25. So you can really see that with iMachining, we're giving you a lot of choices here with the feed rates, and the user doesn't have to worry about all that synchronization. What chip load am I running? What's my feed rate? Well, what's my feed rate for that step over? So iMachining is taking care of all that. And if we were to calculate level 2 and just see our feed rate there, we go down to 6 minutes. And for the really aggressive customers, we can go all the way up to level 8. You can see level 8, we get a little bit wider cut. We're going up, we went from 60,000 to 95, and now we're up at the 8,000 RPM range. If we calculate this tool path and simulate, we go all the way down to 1.5 minutes. So with iMachining, you have a huge range of strategies that you can go with. You can run same feeds and speeds that you run normally, and you'll still get better tool life, more efficient cutting, and better on the tool and the machine. With SolidCAM's iMachining Wizard, even level 1, 2, or 3 is going to beat the cycle time of what most customers are doing with machining today. And it's very easy, as we see going up to level 6, 7, or 8, to achieve those feed rates, because iMachining is managing all of this stuff. So